Excellent. Thank you very much. I'd like to thank all the organizers for allowing me to speak. And I'll do something as different as I can from the previous two speakers, though this is a new glimpse into something that I think is emerging and will cause quite a stir. Talking about PFAS in general, but in consumer products, and especially various pathways they have into the environment. Let's see if I can advance this. I can. Okay. So the reason I'm talking is that we have a rapid spectroscopic method for detecting fluorine, and this is total fluorine analyses. But what I'm able to report on this time is the follow-up, where we use this spectroscopic technique in 3 minutes per spectrum to go through and identify where fluorine is and where it isn't, and then narrow down on the ones that have it. And this is a much cheaper technique in the sense that we don't have to do a full LC mass spec analysis, which is, of course, the golden standard for how you do these things. The instruments you saw on the previous slide are fairly extensive, but we're trying to commercialize those and make them more available. But what this technique allows us to do is to look at various sources of fluorine in the environment and how they get there. And the first thing we found several years ago already is that total fluorine is way higher than the individual analytes you can see with the LC mass spec. And the reason for that is pretty straightforward. The LC mass spec is a wonderful sensitive technique, but it targets the analytes of interest. And if they're not in the library, they don't show up. And that means that you can do some non-targeted analysis as well. You can do a total oxidizable precursor assay to get around it. But in general, you're looking at only 1 to a few % of the total fluorine compounds that are there in the present. And this is an example out of a paper, not ours, but Scott Mayberry's old paper, showing all the various transformations they suspect happen between a typical fluoropolymer molecule in ethyl phos as it turns into an ethyl fosa. It goes through a bunch of different permutations, and you don't see all these things, but they certainly all exist in the environment for some amount of time while they transform. And this precursor load is significant, and it leads to eventually PFCAs that are, or some sort of PFSAs that are visible at the end of the chain. We have a method that we've tested several ways because people didn't believe us at first that there was that much fluorine out there. So we tested it against CIC, which is also a very good method for total organic fluorine measurements. We also use neutron activation, which is well known as well. That you need a reactor for, so I wouldn't recommend that highly, but it's possible to get the same answer on food packaging on all 3 of these methods. And it shows that there's a lot of fluorine being applied, even if we can't measure all that by extracting it out and putting it through LC mass spec. And so this is the takeaway that, there's, and Lara Schultz in her thesis at Stockholm came up with an observation that there's a lot in the environment that we don't see. And we're driving our regulatory limits with ones that we do measure. And of course, there's well-known consequences of PFOA and PFAS, which Mindy and others have talked about today, with the negative health risks. But if we can only see 1% of it, where's the rest and where else might it be? And we did this once before with the fast food wrappers, because that's what we're talking about up till now. We see a total fluorine measurement as sort of a complementary approach. Go and screen a lot of products, and then if you find fluorine where it's not supposed to be or where you didn't expect it to be, you can drill down and actually take some subset out for a targeted analysis, which is more expensive and time consuming. We did this with fluorinated compounds that had the unintended consequence that several of the companies that were then named in the paper got rid of it, which is a good outcome. Science driving policy in that sense. So things that we're doing now is we're engaged, and you may have heard yesterday, Whitney Carnard gave a nice talk on sampling and screening lots of Great Lakes fish. We've only just begun that project, but we're going to do somewhere between 700 and 1,000 fish over the next year, which will approximately be 10 times the number of fish ever analyzed by LC mass spec. And we will be able to look at trends and then be able to drill down on those trophic levels of fish and identify things like that. We've published last year a firefighter's PPE guide on where the fluorine chemicals are and how they come off. And there's several other papers in process. But today I'd like to talk about one that's near and dear to many of our consumers, is just cosmetics. And we are in the process of publishing this paper that shows that cosmetics have 2 direct and indirect path into the consumer of PFAS exposure. If cosmetics contain PFAS, then they could be applied to the lips, to the eyes, to the face, or anywhere else, and be absorbed dermally or by accidental ingestion or through the tear ducts, or even inhaled. Or more likely that when 99% of that stuff is thrown out, it will end up in the landfill and be in our drinking water for years to come. a la some of the presentations you've already heard here. And so it's only an issue if there are PFAS in cosmetics. And interestingly enough, before COVID, these numbers are, the cosmetics industry in the United States, or North America, let's call it, is about $20 billion a year. So it's a huge industry. There have been 3 prior studies published, including this gem by Lara Schultz, again from Sweden, in 2018, that they looked at 31 different cosmetics, and they found 39 PFAS available in those cosmetics. And there were a couple of earlier ones out of Asia that tested a few dozen. And so there were examples of PFAS being used in cosmetics. And so we wanted to test the North American market. So that meant Canada and the US. And so we did our job and found 231 separate cosmetics, put them in front of the beam, and measured fluorine levels. And we look at such things from eyebrows, concealers, to face makeup, which includes a covering and all sorts of things like that. But the 2 areas we did that the Swedish didn't do were the mascara, the waterproof mascara, and the lips, the everlasting lips. And often these are nowadays, if you have any teenagers at home, these are the liquid lipsticks as opposed to the old-fashioned roll out the solid lipsticks. These were found to have high levels of fluorine in many of them. You can see the red bar versus green bar. The green bar is basically no detects, and the frequency with which the number of products tested with no detects. The orange bar is in the middle. They're above detection level, but probably not high enough to be effective. So some sort of below our LOQ maybe. And so there's a considerable percentage of products that had fluorine in them. And then we decided to look at those to see what way they were. And a subset of 29 of the high fluorine samples were then tested at Indiana University, and we took them through all the standard 537 methods after some extraction. And we also did something new. We did GC mass spec as well as LC mass spec, we being Marta Vernier at Indiana. All 29 of them had identified PFAS, sometimes in trace amounts, sometimes in rather staggering amounts. There was a significant, as you can see from the blue on this graph, a significant fluorotellular alcohol contribution, which hadn't been observed before because nobody had tried GC mass spec before on these. And there were also, for the first time, observation of methacrylates, and quite a few of them actually. Methacrylates were detected in several of these things, which are usually associated with polymeric forms, but they don't have to be. And in North America, they looked pretty consistent. There was a large chunk of these fluorotellular alcohols and methacrylates, but there were also certainly some PAPs and dipaps found. And there were a few of these straightforward PFAS, the PFOA and PFHXA and things like that that you can observe. When we dive into the categories found, we found both a wide variety of C8 and C6. It was not purely C6 anymore, but there was, the detection frequency, the number of times we found 8,2 was about a third, whereas about half the time we found 6,2 PAPs. We found 100% of 6,2 fluorotellular alcohol, but 92% 8,2 fluorotellular alcohol. So that doesn't sound like it's being phased out anytime soon. And carboxylic acids were present, but the detection frequency wasn't 100%. It was on the 10, 20, 30%, 40% in some of these things. There was some of the long ones were there, which were, again, not expected. And interestingly enough, the Canadians were different from the US, and we're not quite sure why that is, except we believe that maybe they have a different source of their cosmetics, or at least the PFAS within their cosmetics. Often they're the same name brands. We checked all the major name brands, with 230 of them available. We checked a couple of Canadian companies, but basically we looked at the multinational corporations. All 17 of the Canadian ones also had PFAS. So anything that was high in fluorine did have measurable PFAS, and several of the things that were low. But the difference was that there's still fluorotellular alcohol significantly, and methacrylates were the new products we had found. But there are also some sulfonates present in the Canadian ones, and that confuses us. We don't know why that would be, but that's interesting. And we report on this in the context of, there's a couple new categories of these things found. It's much more broad than we expected. It's widely used, and a lot of the cosmetics have these things in it. There are always some by every manufacturer that don't, but they are targeted more towards ones that say water resistant or long wear. And specifically, the categories of liquid lipsticks and waterproof mascaras are almost surely heavily fluorinated from PFAS. The amounts, if you look at the quantified amounts from, again, the targeted analysis, which is only a fraction of the total fluorine, but they do range from trace levels to some fairly significant. These are in part per billion levels, not part per trillion. But we see something, one fluorotelmer in that foundation, and the second one there, unlabeled, but foundation number 2 had 10 parts per million, 6,2 FTOH in it, which is pretty significant. We get hundreds of parts per billion of PAPs and fluorotelmer alcohols, and even some methacrylates up there around that range. There's that one liquid lips there with 568 part per billion methacrylates in it. Again, a 6.2 there, but the 8.2 is not gone, that's for sure. So we get some trace in very high quantities on the target analysis. We know that there could be inorganic fluorine used in some of these. Lara's already on top of this. She's asking, are there possibly labels to advise customers not to, like the EWG website? Well, unfortunately, none of the 29 analyzed had any PFAS or anything close to fluorine listed as an ingredient. Some of the 231 of the larger group had the possibility of saying that they had fluorinated mica in there, which is a synthetic mica. They don't call it fluorinated, they call it synthetic mica. But those are treated with PAPs, so we know those are PFAS. They just don't mention it. Some of them do contain talc or these synthetic micas or clays. And if there's a clay on a foundation and things like that, that could be an inorganic source of fluorine, and we have no way of distinguishing that from our rapid screen. But when we put them in front of the, we broke them down and extracted them and put them in LC mass spec, we did see individual analytes, all full of PFAS. So while we can't generalize by company or anything like that, there's just not enough data to do that. But we can generalize that the labeling in North America, certainly as compared to what you'd see in Europe, the labeling needs to be seriously revisited. There's nothing that would indicate to EWG or anybody else that this would contain fluorotelmer alcohols at part per million levels. I'm not sure that they should, and you can talk about essential use of liquid lips and such things like that, but that's a concern that we have going forward with this. So we'd like to publish this and get this out there and have people aware of these categories.
Fran, 3 minutes.
Thank you. I'd like to acknowledge all the folks who worked on this, the students listed on the front slide, as well as the collaborators who helped collect and secure funding from the Canadian Research Council, Natural Science Engineering Research Council, and Climate Change Canada, and some NSF funding for the students. I will already answer one of the chat questions that came up, of course. It doesn't matter how much has been found in makeup, is it actually getting in the people? And I think the answer to that is we're not exposure scientists, so we can't do that part of the study. But if it's present, there's a published study out there that says lipstick wearers eat on average about 7 pounds of lipstick in a lifetime.
Oh my God.
That's a fairly startling number. It came out a few years ago, but that was back when the previous speaker, Jenny, said that it was full of lead back in the days, and that was not good. But now it's full of PFAS, and even if you don't eat that many pounds of lipstick, there's a direct ingestion path for it. And that means that you are worried about this. Again, I'm still worried about the environmental aspects of this, because we manufacture tons of this stuff and we put, most of it's worn and then disposed of, and it will go into the recycled or into the landfill in this country, or in the Canada as well, and we'll get in our drinking water supplies. So happy to take questions. My email is at the bottom here if you are able to see that. You're welcome to send questions by email, but I'll answer some now if that's possible.
Yeah, we have a minute left in your time, so if there's one that you see.
EWG does not know about this paper yet, and it does not know about PFAS and its products. It's going strictly off this labels. We did not test lip balm. That's on a list of things that can be done.
There's always more to test, right?
Oh, there's always more. And it's the thing that limited us here was the cost of the cosmetics. The only trend we can say is that the fluorinated ones are a little more expensive than the non-fluorinated ones, which makes some sense. But they're better, of course. They last longer and, of course, have higher product value. And we intend to publish this. It's under review right now, so it should be out shortly in a few weeks. And so we will certainly challenge the companies to do a little bit of a better job of labeling, and they'll say that it's perfectly safe. Of course, that's for other people, experts, to argue whether the exposure is a reasonable concern or not. We just note the presence of these things.